Good morning, all of you. I'm Dr. Raju Anita. I'm the faculty for Artificial Intelligence. Today, we are going to learn the session number 7 in CO2. In this session, we are going to discuss about what are the local search algorithms. So, this is the local search algorithms and what we are going to learn in this local search algorithms. First of all, we should know what is the optimization problem. So, what are the optimization problems? Why we are going to discuss these optimization problems? So, you should understand what are the optimization problems. Then we are going for local search algorithms. How these optimization problems are interrelated to local search algorithms. Optimization problem. So, optimization problem is the problem of finding the best solution from the given set of feasible solutions. For example, a problem is having so many kind of solutions. From that solutions, we are finding one solution is the feasible solution. That means what is the optimum solution for the given set of feasible solutions. That is called it as optimization problem. From that optimization problem, how we are interlink these local search algorithms. Local search algorithms comes under optimization problems. That means you are finding the best solution for the given set of feasible solutions. So if you are having any problem, that problem is having the set of solutions. From that set of solutions, which solution you are finding out as the best solution, that is called it as optimal solution. Now we are discussing under this optimization problem what are the local search algorithms. Local search algorithms where the path cost doesn't matter and only focus on the solution state. So it doesn't matter about the path cost. For example, you have a traveling salesman problem. In the traveling salesman problem, how we are going to find it out the best path? So if you are starting from the current state and if you are going for the final state, you are selecting that path is the best because that is giving the minimum cost. So whatever the path is giving the minimum cost, that path you are selecting as a best path. But in the local search algorithms, it doesn't concentrate, it doesn't focus on the cost. It only focus on the path to reach to the goal state. So here the main concentrate for the local search algorithms is the current state and the goal state. What is your current state? How we are reaching to the goal state? That's it. So it doesn't focus on the minimum cost of the path, right? And the local search completes its task by traveling on a single current node rather than the multiple paths. It doesn't concentrate on the multiple paths. It only concentrate on a single current node. So see the first point here. This systematically is achieved by keeping one or more paths in the memory. What is the meaning of systematically? So systematically in the sense it has to remember all the available paths. From that available paths it has to select one as the best path. That is called systematic. But here this local search algorithm doesn't concentrate on systematic. Always it concentrate on the current node or current state. What is the current state? Then what is the goal state? I am concentrating only on the current state and the goal state. That is the theme of local search algorithm. When a goal is found, the path to that goal also constitute a solution to the problem. Whenever the goal it is found, then it shows this is the path which gives the solution for the current problem. Right. And here, suppose you are taking some problems, the path of the goal is irrelevant. So that is not a constant. We are having different kinds of paths to reach to the goal. For example, 8 queen problem. So in the 8 queen problem, we cannot say that this is the path you have to follow to reach the goal. We can have different types of paths that are available. But which path you need to select, that is based upon the best path. So if you are going for this path, then only you can reach to your goal. Okay, the same general property holds for many important applications. Where you are using this these local search algorithms. We are using these kind of local search algorithms in different kinds of applications like circuit design and factory layouts and job shop scheduling and automatic programming, telecommunication network optimization, vehicle routing, and portfolio management. These are the different kinds of applications where we can use these kind of local search algorithms. Now you have to understand the main point here. The local search algorithm is the local search algorithm only operates on a single current node, so it does not concentrate on multiple paths. It only concentrate on neighboring node. That is the first point you need to remember. The second point is the paths may be the irrelevant. That means there may be the number of paths that it will be exist, but the main goal of this local search algorithm is the goal state. What is the current state and what is the goal state? And what are the advantages then for this local search algorithm? There are mainly two advantages for the local search algorithm. The first advantage is they can use very little memory. Why we can say that they can use very little memory? Here we are not remembering all the states that are available. Only we are concentrating on the current state and the neighboring state. So we are not concentrating all the paths that are available. So we no need to remember all the states that are available states. So here we are using very little memory. And the second advantage is they can often find reasonable solution in large or infinite state space. So if we are having a continuous state spaces, then we can able to find a reasonable solution within a time, stipulated time. That is one of the advantages of local search algorithm. So here one more thing, the question which will be arise is the local search algorithm works for pure optimization problems. So whenever this question arises, the answer should be yes. Yes, the local search algorithm solve the pure optimization problems. What is meant by pure optimization problem? Pure optimization problem means each node in the problem gives the solution to reach to the goal state. That is called pure optimization problem. So in the aim of this pure optimization problem is to find the best state according to the objective function. So for every problem there is an objective function. Based upon the objective function only we are going to the goal state. So here in the pure optimization problem, each node it will give the solution. So in the local search algorithms is also work for pure optimization problem. A complete local search algorithm always finds a goal if one exists. If the goal is exist, always the local search algorithm finds a goal. An optimal algorithm always finds a global or minimum or maximum. So you need to understand what is the global maximum and what is the global minimum. What is the global maximum? If the evaluation corresponds to an objective function, then it finds the highest peak, which is called it as global maximum, highest peak. This you need to remember this terminology, highest peak and lowest value in the valley. So we can call it as a valley because we are calling it as some applications of local search algorithm. Hill climbing is also one of the algorithm comes under the local search. So that's why we are using this terminology. What is the global maximum? What is the local minimum? Global maximum means whenever it is concentrate on the evaluation function, then the highest peak of the value is called it as the global maximum. Next, global minimum. What is the global minimum? If the evaluation corresponding to the cost, then the task is to find out the lowest value, which is known as the global minimum. So these two terminology you should be aware of that. Next, what are the different types of local search algorithms? What are the different types of local search algorithms that are available? So we have different kinds of local search algorithms. The first one is hill climbing. Hill climbing, simulated annealing and local beam search. So we are discussing these three in our syllabus. Hill climbing, simulated annealing and local beam search. So under the hill climbing, what is the meaning of hill climbing. How this hill climbing is achieved in the local search algorithm. So we are discussing about the hill climbing. Hill climbing search is a local search problem. The purpose of hill climbing search is to climb up a hill and reach the top of the mountain. So you are climbing up the hill and your task is you need to reach to the peak of the mountain. That is my goal. So you are standing the current position and I am giving a task for you to reach to the highest or peak of the mountain. So that is my goal. And what is the current state? Then how could you achieve your goal? So here I am giving a task for you. I am leaving you in a thick fog and I am saying you to climb up the hill in a thick fog. What is the meaning here? What is the current situation that is in front of you? You cannot able to see your surroundings. Only you can aware of that your neighboring step only. You are not able to see for further steps ahead. No, you can able to see only the neighbor steps that are available from your current step. So how could you climb up your hill? First, you are in the current position. What is how could you go for the next step? You are saying what are the steps that are available in your neighborhood. So you are having some steps that are available to your neighborhood. So always you are seeing that which one is the best step from my current step. So I have four neighboring steps. I can move up, I can move left, and I can move right, and I can move down. So these four steps are available for you. Then how could you go for further? You will check whether my next step is better than my the current step. Then you are moving up. Okay, my next step is better than my current step. Then you are adopting that new step is the new solution and you are moving forward to the next step. So this procedure is called it as hill climbing. Right. So I'm showing you here on this notice board. Can you able to see? And see here. So here I have this. What is the procedure we are having here is first you need to climb up the hill, right? So how to climb up the hill here? So we have here current step. So now we are in the current step, and you need to move from this is. So now we are in the current step. This is my goal. This is my goal, and you are here in the current step. So how could you move from the current step to the goal state? This is my goal state and peak of the mountain. So how to move this from here? I can move for here. So whenever you are here, this is the current step. I want to move to forward to up. Whenever you want to move to forward to up, now you are seeing what are the available steps that are existed. So in this you have left I can move, right I can move, to up I can move, down I can move. But is this the, if I am moving from towards to right, is this the best solution from the current state? No, this is not the best. So you are not adopting this as a new solution. So whenever I am moving, I am taking this as the next step. Whenever I am moving towards to left side, I am not reaching to my the goal state. And this is not the best from the current state. So you are not taking this step as a new solution. Now I am selecting this. So I am selecting this because that is the new solution which it is better than my current solution. I am moving forward. Again, what are the next? I am moving forward, up and forward, up and forward, up. I reach to the goal state. Okay, in this manner you can reach your goal state. Okay. So here this is the hill climbing, and next we are seeing this how it will be work for and what are the terminology you should understand in the hill climbing. So what is the meaning of terminology? Before you are going for the terminology what we are using in the hill climbing, first let us start how many types of hill climbing exist. So here we have simple hill climbing is exist. What is the simple hill climbing? Whatever I explain now, you are in the current state and you are selecting the next state based upon the current state. If the next state is better than the current state, you are moving to the next state. That is simple hill climbing. The next one is steepest ascent hill climbing. What is the steepest ascent hill climbing? So it is searching for all n solutions in the neighborhood. Just I explained, left I can move, right I can move, up I can move, down I can move. So all n solutions you are having in the neighborhood. From that n solutions, you are adopting only one solution which is giving the better solution than the current state. So if that solution is giving the better solution from the current state, then you are selecting that solution is the best. Next, that is called steepest ascent hill climbing. Stochastic hill climbing. Stochastic hill climbing means, so we are having n number of solutions. So in those n number of solutions, you are selecting randomly one solution randomly. I am not saying this is the best solution, that's why I am taking. So here randomly one solution you are selecting based upon the probability. Right, so this is called it as stochastic hill climbing. This stochastic hill climbing we are using in simulated annealing technique. The next searching algorithm we are using, and this steepest ascent hill climbing we are using in hill climbing. Next, hill climbing. Right, so before you are going for this hill climbing algorithm, you should be aware of that. What are the terminologies we are using for this hill climbing? So I'm showing you that what are the terminologies with the help of diagram. Please make a note this. Right. So I'm using here the board and I would like to show you what are the terminologies. So here in this terminologies I would like to design one diagram. So you should aware of this terminology, then you could able to understand this algorithm very clearly. So suppose here I used, so this is an objective function. Objective functions. So as I told for you, for every problem there is an objective function exists, and this is a state space. What is the state space of the problem? And this is a, for example, this is a called it as current state. Current state. What is the current state? And this is called it as a shoulder. What is shoulder? Shoulder. What is the shoulder? It is also a flat area where the summit is possible. This is a flat area where the summit is possible. And next one is global maximum. This is called it as global maximum. So as I told for you, global maximum, it is the highest point on the hill, and which is called it as global maximum. And this is called it as local maximum. What is the local maximum here? It is the peak higher than all other peaks. Peak higher than all other peaks but lower than the global maximum. This is called it as local maximum. And this is called it as flat local maximum. This is called it as flat local maximum. So this terminology you should be aware of that. Are you able to see objective function? This objective function is for every problem there is an objective function, and these x-axis state spaces. And now here this is the current state. What is the current state? And this is called just shoulder. 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 Shoulder means flat area where the summit is possible. And this is the global maximum, the highest peak of the mountain. And this is local maximum, the highest but not highest than the global maximum. And this is the state local maximum. This is the flat area, flat local maximum. So if you are clear about this terminology, then we could able to clearly understand the algorithm what we have. Okay, so once is this clear, we are going for next algorithm. And what are the different kinds of hill climbing techniques? Simple hill climbing technique, and we have steepest ascent and stochastic, and then wait a minute, I'm going for the slide. Wait a minute. I'm going for my slide. Stochastic and random restart. Random restart is also there. Random restart algorithm is also there. But even though we are not discussing here the random restart algorithm, just we are concentrating on simple hill climbing and steepest ascent and this is steepest ascent and stochastic hill climbing, but we are not concentrating on random. So, are you understood about steepest ascent hill climbing? Now we are going for example of hill climbing. What is the example we are having in hill climbing? First of all, you should understand hill climbing algorithm. So, in this hill climbing algorithm, first we have the first step is evaluate the initial state. It is also goal state. First, we have to know what is our initial state and what is our goal state. If this initial state and goal state is equal, then you're just quitting out. Otherwise, you're starting from the initial state. That is treated as the current state. So, you want to climb up a hill. Now you are in down. That is your current state. What is your goal state? You have to reach the peak of the peak of the mountain. So that is your goal state. So you need to continue these iterations. New operator means new step. So you from the current state you are finding the new step. So if you are finding the new step, then immediately you are making that the new step is the current state. So how long you will repeat the same process? You are repeating the same process until you are reaching to your goal state. So this is the process here. How to evaluate the new state? So whenever you are in the current state, that state is the goal state or not, you have to check. So I'm climbing up the hill. Now I am in the peak of the mountain. You have to check whether I reach to the peak of the mountain or not. If I reach to the peak of the mountain, then what is the need to go up? That was my goal state. Just I'm stopping there. Otherwise, you are checking what are the neighbors of my current state. If you are having the better solution than the current state, then you are going for your new state. That is the new state from the current state. This is the hill climbing algorithm. Now, blocks word problem. This is one of the blocks word problem we are having in hill climbing. Now, I want to explain this with the help of a board. You please be here. I would like to explain with the help of the board. Now, here. Is it clear? Okay, now here I have is a problem, that is the problem here is I have a current state and the goal state. What is the current state here? I have the blocks with A, D, B and C and B. This is my current state. What is my goal state? The goal state is D, C and B, A. This is my goal state. This is the current state, and from the current state, this is the goal state or final state. So here I need to go from current state to goal state with the help of hill climbing. How could you do with the help of hill climbing this? First assign the object heuristic function. The heuristic function for B is 0 and for this one is -1. This one is -2. This one is -3. So the total, what is the heuristic function value for this is -3, -2, -1. That is -6. And here the heuristic value is 0, 1, 2, 3. This is the heuristic value. Heuristic function for this is 6. So I need to move from -6 to +6. That is my aim. So for this, first what I am doing here is, first what is the topmost element here? A. So keep that A and keep it on the ground. So I am keep it A in the ground and the value is 0. What are the rest of values here? The rest of values is D and C and B. So what are this? 0, -1 and -2. So this is -3. So I reduce the heuristic value -6 to -3. And then I am going for next one is B, C. And you are keeping that A and then the topmost is D. So here this is 0 and this is 0. This is 0, -1. It is reduced to -1. Right, heuristic value. This heuristic value is 0, heuristic value is 0. Now again keep down A, and this is B, and this is 0, 0, and this is, here I am giving C, this is my 0, and B, I am keeping B is out. So here I am writing C and this is B, 0 and 0. Okay, now here what is my goal state? On A I have B, so I can keep B here on the top of the A. Now here you can have A, B. So this is 0 and this is 1. Now keep C on the top. This is 2, and now keep D on the top. This is 3. So heuristic function is 6. So I reach to this. So are you understood this one? Now this is the way how we are solving the hill climbing, problems in the block word problem. So I am repeating once again this problem if you are not understand. So here I'm giving another problem here for solving of this kind of problems using hill climbing. I have an initial state and goal state. If you are having initial state and goal state, how we are applying the hill climbing to solve those kind of problems. For example, here I have the blocks A, B, C, D. This is my initial state, and my goal state is D, B, A, C. This is my goal state, for example. So how to apply the hill climbing? First calculate 0, -1, -2 and -3. And this is 0, 1, 2, 3. So what is the heuristic function for this is -3, -2, -1, that is -6. And here is +6. I need to move from -6 to +6. So first of all, what is the topmost value? D. Keep the D here, and this is 0. And what are the rest of the elements here? The rest of the elements is A, B, C. Keep it as it is, 0, -1 and -2. Now again take it as D and keep C. So here I am keeping C out and I am writing A, B, and this is 0, -1, and I am keeping on the floor. See, I am keeping on the floor and I am writing 0. Now I have to move B. So whenever I am moving B, and I have to see my goal state. So B is on D. So I want to keep that D, and here is B. I am keeping B. Then this is A and this is C. Okay, this is 0, 0, and this is 0, 1. Now after D I have A. You can keep that here on this D, B and A. So this is 0, 1, 2. And again the next step is D, B and A and the C. So here is 0, 1, 2, 3. I reached the heuristic function is 6. So this is the way how we are solving your problem. Okay, understood this one? Next, this is the problem here we explained. So you can see this here, heuristic value. This is a heuristic function is equal to -6. Why -6? 0, -1, -2, -3. That's why -6. So first I am keeping A on the floor, and the rest of the values I am keeping. So it is again you are calculating the heuristic function. This is 0, 1. 0, -1, -2, that is -3. And again in this step you are keeping again D on the floor and again calculate 0, -1, and now you are keeping everything is on a floor. Now go for your goal state. So based upon the goal state you are arranging that and you are calculating the heuristic function, that is equal to +6. This is the way how we are solving your problem in hill climbing. The next one is the limitations of hill climbing. This is very important, the limitations. What are the limitations of hill climbing? In the limitations of hill climbing, the first limitation is local maxima. What is local maxima? A local maxima as opposed to global maxima. So the global maxima means the highest, the peak of the mountain. Local maxima is that is the higher than, but that is the higher but not higher than the global maximum. That is called it as local maximum. So I would like to show you the local maximum with the help of a diagram. So I'm moving towards to notes board, and you can see here with the help of diagram how you can here local maxima. How could you find this is a local maxima? This is, as I told for you, here is a local maxima and here is a global maxima. Here this is the local maxima and this is a global maxima. So once suppose you are moving to the highest peak of the mountain, you are here, but you are thinking that that is the highest that you reach to the mountain, but there is the highest more, that is the global maxima. So you are thinking that I reached the mountain, but this is not the highest peak of the mountain, this is the highest peak of the mountain, global maxima, and this is the local maxima. So this is one of the disadvantages of hill climbing. You are thinking that I am giving the current state and your goal state is to reach to the mountain, but you are reached to the local maxima and you are thinking that that is the highest and you reach to the highest of the mountain, but you are not reached. This is the global maxima, this is the highest place. So this is one of the drawback your hill climbing. The next drawback is plateau. Suppose here there is a plateau means the flat surface and then there is a mountain. You are climbing the mountain, you reach to here, you reach to here. So whenever you are seeing your surroundings, you cannot able to see the best solution to move to upward. So if you are going to move here, this solution is not better than this, but you moved and you moved, this solution is not better than this, then you may be the chance for stopping of hill climbing. That means you may get the confused, you may get it becomes very difficult for you to climb, to decide that which direction you need to go. This is one of the disadvantage, that is called it as a plateau. So the flat surface you will found. So in this it is very difficult to identify where I have to move to the climb up the mountain. This is one of the disadvantages. The next one is ridge. The mountain is like this. So like this. See. The mountain is placing like this. This is called ridge. Now you reach to your mountain, but here I am climbing out my mountain. So you are finding out all the equal, and you are finding out all the equal local maximas. So here it is very difficult to you to reach up to the goal state. So this is called it as ridge. So these three are the limitations of your hill climbing technique. Okay, so I think this hill climbing is very understood for you. Then you are going for steepest ascent hill climbing. What is an algorithm for steepest ascent hill climbing? So as I told for you, we have stochastic hill climbing and steepest ascent hill climbing. So this is an algorithm based upon our explanation how we are. First, you are evaluating the initial state, and it is also a goal state. So suppose the initial state is your goal state, just you are quitting out because I am already on the peak of the mountain. Then what is the need to move up? That is my goal state. You are just quitting out. Otherwise, you are continuing from the initial state as the current state. Now my initial state is the current state. Now you are repeating, finding out the next step based upon your current state. So next you are seeing all the successor steps or neighboring steps from the current state. If you are finding the neighbor state is the better solution than the current state, you are selecting that state as the current state. You are repeating the same procedure until you are finding out your goal state. That is called steepest ascent hill climbing. Okay, the next one is simulated annealing. What is the meaning of simulated annealing? So I think all of you are aware of the simulated annealing, maybe knowingly or unknowingly. When you are in your childhood, you may play that. Excuse me. You may play that a game that is fish, water fish in a tank. So maybe you played that game. So there is a fish tank. In that fish tank, there are some rings available, and the water, in that water some fishes it will be there. The main goal of your is you need to pressing the button, and the rings will go up in the water, and those rings hook to the fishes. Suppose three fishes are there in a fish tank with water. Some rings are there. You are pressing the button by applying the pressure. So whenever you are pressing a button, the rings will go up and the rings will hook to your fishes in the tank. So that is our goal is all the rings in the water has to be hooked up to all fishes that are in the tank. That is the game. So I hope so most of us are played this game, and when we are in the childhood, that game is simulated annealing. So that is that it is following the simulated annealing. What it mean, when how you are going to play this game here, whenever you are pressing that button, then all the rings in the water is going up and start hooking onto the fishes. So if you are once suppose in the water there are 10 rings, 3 fishes are there. 10 rings and 3 fishes. Whenever you are applying the pressure on the button and press, those 4 rings are going up and hooked to 2 fishes. Only 2 rings are left. Then what you will do? Automatically we are carefully playing the game by reducing the pressure of pressing the button. So this is the simulated annealing. That is, once you are making the pressure more, the probability more, then you are trying to decrease that, because once you are giving the pressure more, all the rings that already hooked will be released. So then what will happen? You may lose the game. That situation will happen. So automatically you will reduce the pressure of pressing your button. That is called simulated annealing. Here simulated annealing is an effective and general form of optimization, and it is useful in finding global optima in the presence of large number of local optima. So, and this annealing, the name it is referring to analogy thermodynamics. So that means you are taking a metal and you are heating that metal in high temperature. Once it is reached to the high temperature, then gradually you are decreasing the temperature and you are making cool of the metal to make the metal as a strong. That is simulated annealing. So this algorithm is basically hill climbing, except instead of picking the best move. So instead of picking the best move, randomly it is selecting a move based upon the probability. Right. Suppose based upon the probability, if you selected a move that is decreasing our exponentially, then we are taking that is the badness of the move. Right. This is about the simulated annealing. Next, local beam search. So this local beam search is one kind of local search algorithm. In this algorithm, it holds k number of states at any given time. So at any given current state, you are having k number of states. At the start, these states are generated randomly. So at the current state, these states are generated randomly. From that k states, you are selecting one state based upon the objective function, which it will maximize the value of the objective function you are taking. This is called it as k states or k number of successor algorithm also. Otherwise, we can call it as local beam search. So here this is an algorithm for local beam search. So this is a function beam search, what you are processing, problem comma k. So problem means what is an objective function for the problem you are passing as a parameter, and k, here the k number of states, and return a solution that starts with the k randomly generated states. So here we are having a loop. Generate all successors of all k states. First, generate all successors that are available for k states. If any one of the state is the solution, select that solution and return. Otherwise, select one state which is the best for the solution, which is the current solution. So if that state, if in generated successor, that state is the best state, then move to the best state from the current state. This is our local beam search. Hope you all understand all these topics from CO2 that regarding to the local search algorithms. Okay.